Hello, this is Professor Muskan and welcome to my YouTube channel Ansari Academy. Today, in our first session of oscillation, we are going to study the topic named periodic motion. So, in our daily life, we come across various kinds of motions, like example, rectilinear motions and motions of a projectile. But both of these rectilinear and projectile motions, they are non-repetitive in nature. But this periodic motion, the body goes on repeating. Therefore, this periodic motion is a repetitive motion. We are going to discuss about the periodic motion. So what it is? In periodic motion, body goes on repeating the motions. It repeats, the body repeats the same set of movements again and again after a definite interval of time. Let's see a few examples for periodic motion or a repetitive motion. So like example, for the periodic motion, motion of the moon around the earth. Motion of the moon around the earth. Here we can see that the moon rotates around the earth, around the earth with a definite interval of time. So hence, motion of the moon around the earth. Okay, let's see some another examples for it. Electrons revolving around the nucleus. Electrons revolving around the nucleus. They keep on revolving around the nucleus after a definite interval of time. So hence, this is also an example. Electrons revolving around nucleus. Another example, which keeps on moving with a definite interval of time, is a motion of a swing. Motion of a swing. Whenever we sit on the swing, it keeps on moving to and fro directions. The motions keeps on moving with a to and fro directions. This motion takes place with a definite interval of time. Therefore, all these examples comes under the periodic motion. Hence, we can conclude that any motion, the motion, any motion which repeats itself after a definite interval of time is called as periodic motion. Further, let's discuss more about periodic motion with demonstrations and graphical representations. So let's see the first one. What does it say? The first demonstration I have bring for you, that is, suppose an insect climbs up a ramp. Suppose an insect is climbing up a ramp and again that insect falls down. It comes back to its initial position and repeats the process. So for that, we have to draw a graph for it to understand more about the periodic motion about the ant. So what it says, suppose an insect is climbing. Insect is climbing a ramp like this way. Then the insect falls down. It means the insect comes to its initial position, to where it has started. Again, after a definite interval of time, insect again starts climbing. And again it falls. Insect again starts climbing and again it falls. It means this shows the process of insect or the motion of an insect keeps on repeating with a definite interval of time, and the motion is same throughout the graph. If this is the displacement, let's take this as displacement x and the time period p. The whole time considered by this over here, from climbing up to coming down, consider that as time period t. All right, and let this, where it is climbing, let this be a height as h. And this x-axis is represented as time t, and this is the displacement x on the y-axis. All right, now let's move ahead with the second demonstration. If a child climbs up a step, comes down and repeats the process, the same we have seen our first demonstration, the second demonstration says the same. The child is climbing up the stairs. It is climbing up the stairs like this. All right, then it again comes down. Again, the child is climbing up the stair and again it comes down. This process keeps on repeating with a definite interval of time. Again, this graph is ground versus time. So this is the displacement x. And here is the time period. This is the time period to complete one motion. To complete the whole motion, it is considered as time period t. And over here, the height h. All right. So with the above demonstrations, we can make out that it is clear that the motions are held after an interval of time. And these motions are repetitive in nature. These motions are held repeatedly over a definite interval of time. So a body, any body performing periodic motions goes on repeating the same set of movements. At the end of each movement, with the help of demonstrations, you can see that at the end of each of the demonstrations, the movements of the state of the body is same as that it was in the starting or as that it was in the beginning of this motion. The motion is same. The child is climbing up the stairs, again it comes down. It again climbs up, it again comes down. Hence, we can say the set of movements of the state in the periodic motion remains the same. Don't forget this. Also, as we have seen over here, the time period. So what it is, the time taken for one such set of movements is called its period. To complete one set of motion, it is considered as a time period, or it is known as a time period or a periodic time.